Okay, good afternoon, everybody. Afternoon, everybody. All right. We're starting off with any corrections that you need to do. All right. Based on the homework. So I'll tackle that first, and then we will continue with the algebra questions. Okay. So let me know what questions we had that you'd like me to do on the board for you guys. Right. Any questions from the homework? Everything went good for you? Wow. John, anything? Sure. Anything? That's okay. That's okay. No problem so far. Number 3 in exercise 78. Okay. So let's go to exercise 78. Okay. And you're looking at exercise 78 number 3. That's it? Okay. Exercise 78 number 3. Okay. And that said a squared c squared c squared plus acd plus acd again plus d squared. Okay? And what they want us to do there is factorize the following. So how are we going to go about factorizing this situation? Well, if we deal with the first pair as it is already, and then deal with the second pair, let's see what will happen. If we look with the first pair and we see what is common, and we ask ourselves, is A common to the first two terms in the first pair? And the answer is yes. And then you ask yourself, what is the lowest index or power? And that'll be a to the power of 1 or a. So you take that out. And then you ask if c is common to the two pairs, to these two pairs. And you say, and the answer there is yes, c is common. And you take out the lowest power index, which will be c to the power of 1 or c. If you take that out now, then ac taken out from a squared c squared will be ac. Right? And a quick check, of course, is if you multiply it back inside, AC by AC, of course, you get A squared C squared. So you know that that is correct. Then AC into plus ACD will be plus, the A cancels the C cancels with the C, so you get plus D. So your next job is, what do I need to take out from this second pair here, so that I will get AC plus D in brackets. Right? Because remember, the two of them must, if you're doing factorization by grouping, you must get AC plus D. So what do I need to take out from this here to get AC plus D? And the answer is D. If I take out positive D from here, I'll get AC from the first term, I'll get AC from this term, and from this term, if I take out D, I'll remain with D in the brackets. Okay, is that okay? Right. So you notice now that this here is common. The term AC plus D is in brackets. So it comes out as a factor. AC plus D comes out as a common factor now. Right? It's common here and here. So it comes out as a factor. And if we consider the first term, which is AC into open brackets, AC plus D, and remove the AC plus D, then we remain with AC from that part. And in the second term, which is D into AC plus D, and you remove the AC, that is, we factorize it, divide by it, we'll end up with the plus D. And that is what comes in the brackets here. So you end up with AC plus D, open brackets, AC plus D. Now, if you observe something, AC plus D is there twice. So you may choose to leave it like this, or the book may put it into, they may choose to put it as AC plus D squared. They may choose to do that. I don't know what was the final answer in the book, but if they said to factorize by grouping, right, or factorize the following, this is factorization by grouping, and these are the two factors really, this and this, but they so happen to be the same factors, and you call this a perfect square. Anytime you get the same factors, right, coming out, like this situation, it's known as a perfect square. Okay, you understand it? Okay. All right, so any other question we need to look at based on the homework? Those who just came in and the others, or even you have anything else you want to look at right now? Okay. What was, she asked that one? Oh, okay, okay. And you said, oh, you said that you were okay. Right, sorry about that. Okay, what else? What is the next one? We're looking at exercise 73, number 28. Exercise 73, number 28. And that would be 2x, open brackets, x minus 5, close brackets, minus x, open brackets, x minus 2, close brackets, minus 3x into x minus 5. Right, x minus 5. The first thing we'll do when we're looking at this situation here is to make sure that we wrote it down correctly, right? Because it's easy to transfer the wrong signs, and therefore you'll be doing the writing on the wrong question, right? So make sure you have the correct thing in place, which is 2x into x minus 5 minus x into x minus 2 minus 3x into x minus 5. So that looks correct. Then the next thing we do is to expand, because they're asking us in this exercise to remove the brackets in the following. So we'll expand the 2x multiplied by the x first, then the 2x multiplied by the minus 5, and progressively we'll do the same thing along the question. So 2x multiplied by x is 2x squared. 2x by minus 5 is minus 10x. Right? Then you're going to multiply minus x by x, and then minus x by minus 2. Minus x by x is minus x squared. Right? Minus x by minus 2 is plus 2x. Minus 3x now by x, and then minus 3x by minus 5. Minus 3x by x is minus 3x squared, and minus 3x by minus 5 is positive 15x. Okay? Good so far? Then the next step is to group like terms and evaluate when you group them together. So I'm seeing 2x squared here, minus x squared here, and minus 3x squared here. So you're going to group those three together. Okay, so you have 2x squared minus x squared minus 3x squared. Okay? Then you have minus 10x plus 2x plus 15x. So you write it minus 10x plus 2x plus 15x. Okay, that's what we have so far. Minus 10x plus 2x plus 15x. Okay, so now if we are adding like terms, it's equivalent to adding or combining their coefficients. So the coefficient here will be 2, here will be minus 1, and then the next one will be minus 3. So those are the coefficients, and that will have to be reattached to the x squared term. On this side, you put plus, always put plus, and then put the coefficients in brackets. So it will be minus 10 plus 2 plus 15. And then you reattach the term, which in this case is x. So then you work out what 2 minus 1 minus 3 is. Okay, 2 minus 1 minus 3. Now you could work it different ways. One way to look at it is 2 minus 1 will be 1, and then 1 minus 3 is minus 2. So you get minus 2x squared here. Then you go to the next one, work out what is in the brackets here. This is minus 10 plus 2. We could deal with this first. Minus 10 plus 2 is minus 8. Minus 8 plus 15 is positive 7. So in here will be positive 7, and the plus sign has no effect on it. So it remains as positive 7, and you reattach your x to it. So the answer would be minus 2x squared plus 7x. Any questions on that? Following it? You following it? Okay. Right now, I broke this down into all of these steps. In an exam, you are not required to do all of these steps, right? But I broke it down so you could follow it. What are the steps that you could skip, right? You would be required to do this step, for sure. And then some people might be able to go directly from here to here, right? And if you did it correctly, you would get the full marks. But however, if you didn't do it correctly, and they were allocating marks in between, you wouldn't be able to get it, right? Simply because they wouldn't know how you got from here to here. But if you did get it correct, you would get the correct marks. You understand that? Right. So you could go from here directly to here because you could work it out in your head. You could look at the 2x squared, the minus x squared, and the minus 3x squared and work that out. Look at the coefficients, the 2, the minus 1, the minus 3, and work it out. And put down the answer, okay? Which would be the minus 2x squared. But you would know your capability, right? You might need to write it like this and then come here, or write it like this one and then come to the answer. Okay, but that is the complete working of that problem or that question. You have any questions on that so far? Good? All right. So we're looking at exercise 76, number 9. And in this question, we are asked to find the HCF of the following. Now what we are told in finding the HCF of fractional terms, I'm looking at the first one, find the HCF. In exercise 76, it said factorize the following. Right, sorry about that, which is number 9. Factorize the following. So to factorize this question, we'd have to find the HCF first. And in finding the HCF of fractional terms like this, we look at the numerators separate from the denominators. And in the numerator, you'd realize that there's nothing common, right? The only thing that is common is 1. Because x is 1 by x, y is 1 by y, and z is 1 by z. So the only thing that will be common there will be the number 1. Then, to get the denominator part of the HCF, we look at the numbers below, or the denominators in each term. And realize there's 3, 6, and 9. And you ask yourself, what is the highest common factor there? And in that case, the highest common factor will be 3. So 3 is the highest common factor. Now, if 3 is the highest common factor, it means now that we will be taking that out of each one of these terms as you go along. Now, if you take 1 out of x, which means divide x by 1, because we're focusing on the numerators now, we say x divided by 1 is x, right? Over, then you say 3 divided by 3 is 1. Then you go to the next term, which is minus y over 6. And the first thing you're going to determine is what sign we're going to write here. Now, because this is a negative term, minus y over 6, and we're going to divide that by a positive number, which is a third, we know that the result is going to be negative, because whenever we divide unlike terms, the result is negative. So I have to put a negative sign there. Okay, and the same thing happens. Look at the numerators first. Y divided by 1 is y, over, then look at the denominators. 6 divided by 3. 6 divided by 3 is 2. So that'll be that one. Then we go down to the last term, which is the positive z over 9. And if you divide in two positive numbers or terms, the result is going to be positive. The signs are alike. So we say z divided by 1 is z over 9 divided by 3 is 3. So with that, we would have done the factorization. And always is a good thing to multiply it back in and see if you would get the original question or original expression, and you'd realize you would get it if you multiply the 1/3 back into the equation by each term inside of the brackets. You would get the same answer. Okay? So is that okay for the person who asked about it? Right. Next one. Okay, so in exercise 78, number 4, we are asked to factorize the expression 2pr minus 4ps plus qr minus 2qs. We are asked to factorize this. So again, we consider the first two terms as one pair, or the first pair, and then the next two terms as the second pair. We are now going to look in the first pair. We are now going to look at the first pair and ask what is the highest common factor, what we could take out as the highest common factor there. And if we compare the numbers first, which is 2 and 4, we would see that 2 is the highest common factor among the numbers. And then we would see that p is common in both of the first terms. So that will also come out as a highest common factor. So that would be what is possible there as a factor there. And 2p into 2pr will give me r. And 2p into minus 4ps, let's look at the whole term first. It's a negative number being divided by a positive, which means the signs are unlike. And therefore, the result is going to be negative when we do that division. We say 4 divided by 2 is 2. And then p in the 4ps divided by p will be 1. So that 1 will be multiplied in the result by s, because s, there's nothing to divide s by except the 1 in the 2p. Okay, so let me go that over again, so we'll clarify that a little bit more. Let me use a different color here. What we understand here is that this 2p is really 2p multiplied by 1. So I'll just put 1 there. Okay, so 2p multiplied by 1, or 2p by 1, this 2p is going to cancel out here, and the r is going to be divided by 1, so we're going to get r. Why I put that here is so that we could see what is going on there. The 2 into the minus 4 will give me minus 2, right? Or we could have looked at it, the minus 4ps, as a whole term being divided by a positive 2p, and that will be a negative result because you're dividing negative 4ps by positive 2p, so you're going to get a negative result. And then 4 divided by 2 is 2. P divided by p is 1, which means that there's a 1, there's going to be a 2 multiplied by 1 here. Multiplied by, now s divided by 1 is s. Okay, now this 2 by 1 by s is really 2s. Right, so I break it down even further. And then now we come and we do the next part. But we have to end up with, in the second factorization, we have to end up with the same thing in the first brackets. It must end up in the second set of brackets when we do the factorization of the second pair. So we're going to end up with r minus 2s if we do this correctly. Now how are we going to end up with r minus 2s? We have to determine what we're going to take out here. And if we take out positive q, we'll end up with r minus 2s. So we'll take out positive q. Now an alternate factor you could have taken out was minus q, but that wouldn't have given us what we wanted in the brackets here. So positive q taken out would give us that. And by so doing, we'd end up with the same terms in these two brackets here and here. Same terms. So because of that, that itself is now common. So we could take that out. R minus 2s is now common. And if we take it out from the first pair, the first terms here, you'll end up with 2p by 1 or 2p, which is here. And if you take it out from the second set, which is this, you're going to end up taking the r minus 2s out, and you're going to end up with plus q. So your factorization is going to be r minus 2s multiplied by 2p plus q. That will be your final factorization. Okay? Any questions on that? Okay, next question. If you have no questions on that, next one. Okay, so your next heading is substitution. And what you'll write as a note for substitution is, this is the process, this is the process, this is the process where we exchange numbers for letters. This is the process where we exchange numbers for letters and evaluate the resulting expression. And evaluate the resulting expression. This is a process where we exchange numbers for letters and evaluate the resulting expression. Example. Example. If x equal to 2, if x equal to 2, y equal to minus 3, if x equal to 2, y equal to minus 3, you're writing it down, and z is equal to 4, and z is equal to 4, find the values of the following algebraic expressions. Find the values of the following algebraic expressions. The first one, A, is 5x minus 2y plus 3z. 5x minus 2y plus 3z. is the first thing we have to find the value of. Now in this question, like all substitution, what we do is wherever we see the particular letter, we're going to replace it with the number that is associated with, but you're going to put the number in brackets, right? That's the important thing, put the number in brackets. What we have found is if you avoid putting it in the brackets, this is where the error tends to take place. And again, if you go onto the CXC website and you check it, they would show you that where you have negative numbers inside being substituted, right? Where you have negative numbers being substituted, if you avoid the brackets, you tend to make more errors. Okay? So let's see what that means. If we make the substitution, then it would imply that 5 in brackets, we'll put what x is. X is the number 2. Then minus 2, and in brackets, we're going to substitute what y is. Y is the value minus 3. So we're going to put minus 3 there. Plus 3, and instead of z now, in brackets, we'll put the number that was being substituted for z, which is the number 4. Okay? That will be equal to, then you work it out. 5 multiplied by 2 is 10. Minus 2 multiplied by minus 3 is positive 6. And then positive 3 by 4 is positive 12. Right? So it's 10 plus 6 plus 12. And that will give you an answer of 28. 10 and 6 is 16. 16 and 10 is 26. And 2 make 28. Okay, so the answer there is 28. Make sure you have that. So that was A, and I'll write down B for you. And I'd like you to work on B now for yourself and make sure that you follow what we just said, the rules. Okay, make sure you follow those rules so you would get it correct. So I'm writing it down now. Okay, so I want you now in part B to find the values of that expression that we see in part B, making the appropriate substitution. Try it now on your own and see what you come up with quickly. Okay, so I think most people look pretty good on this one. All right, and how do we work it out? Well, all we do is substitute the numbers for the letters, remembering to put them in brackets. So this would work out to be 8, open brackets, 2 for x, plus y, sorry, not y, you have to substitute for y. So that would be instead of y, we'll put in brackets minus 3. Then we have minus 2. Instead of z, we'll put 4. And then we'll put below 2, open brackets. Instead of x, we'll put 2. Minus, inside of the brackets, we'll put what y is, which is minus 3. Plus z. Z will be 4, plus 4. Okay? And then we work out what this will be equal to. So 8 multiplied by 2 is 16. The plus has no effect on the term inside the bracket when you remove the bracket. So it becomes minus 3. And then minus 2 multiplied by 4 is minus 8. So the top will be 16 minus 3 minus 8. And the bottom part will be, when you work out 2 by 2, we get 4. Minus 3. The minus changes the sign in the bracket to the opposite sign. So the minus 3 becomes plus 3. And then plus 4 is plus 4. So that's what the bottom would look like. Okay, so you just have to be careful as you go along. Then if you work out the top, that'll be 16 minus 3 minus 8. That works out to be 5. Okay, 16 minus 3 is 13, and 13 minus 8 is 5, so you get 5 on top. And below, you'll get 4 plus 3 is 7. 7 and 4 is 11. So your answer should have been 5 over 11. Right, so substitution is easy when you do it that way. Okay, so the next thing we go on to is binary operations. Binary operations. Binaries, B-I-N-A-R-Y, operations. In algebra, we can use symbols. In algebra, we can use symbols to represent binary operations. In algebra, we can use symbols to represent binary operations. Other than the 4 basic operations. Other than the 4 basic operations. Other than the 4 basic operations of, open brackets, plus, comma, minus, comma, multiply, comma, divide, close brackets. In algebra, we can use symbols to represent binary operations other than the 4 basic operations of, open brackets, plus, comma, minus, comma, multiply, comma, divide, close brackets. Example. An operation is defined by x asterisk y. X asterisk y, which will be equal to 2x plus 3y. An operation is defined by x asterisk y is equal to 2x plus 3y. 2x plus 3y. Find 1. First thing we have to find, 1, 4 star 5. Or 4 asterisk 5, sorry. 4 asterisk 5. That's the first thing we have to do, is find 4 asterisk 5. And the second thing we have to do, part 2, after we do that, is to find 3 asterisk 4 asterisk 5. Those are the 2 things we have to do. Okay, that's the question that we have to do. And in order to do this, what we do is we notice that a binary operation is really a function or an expression which is tied to a symbol. So in this case, the symbol, which is the asterisk sign, is joining two variables, x and y. And it means then that whatever x is and whatever y is, we have to perform this function on it, which is 2 multiplied by x plus 3 multiplied by y. That's what we have to do. That's what the asterisk is telling us to do with these two input values. The secret is to recognize that whatever they give us in numbers is going to be tied directly back to the initial variables x and y. And one easy way to deal with that is to put the numbers directly under the variables or the letters and then evaluate it. It makes it easier to link it. So let's say I had to do part 1, which is to find 4 asterisk 5. Part 1, which is to find 4 asterisk 5. What I'll do, I'll put the 4 directly underneath the x, put the asterisk sign, and then put 5, like this. Okay? What it means to me is that the x is going to be linked to the 4, and the y is going to be linked to the 5. So it means that wherever I see x, I'm going to replace it with 4, and wherever I see y, I'm going to replace it with 5. It's just another form of substitution. That's all. And that's why we did substitution just before, so we know the technique here. So how would we work it out? We just do 2 multiplied by whatever x is linked to, whatever x is being substituted with. And in this case, x is being substituted with 4. So we're just going to put the 4 in, plus 3y, and we're just going to substitute the y with the number 5, because 5 is what is linked to it. So we put 5 there. Okay? So this simply works out to be 2 by 4, which is 8, plus 3 by 5, which is 15. And 8 plus 15 is 23. And that'll be the answer there. So the secret is to notice that there's a linking and a substitution that occurs. So take that. If you don't have it, just take it quickly. Okay, in the second part, we ask to find 3 asterisks, 4 asterisks 5. And what you would learn from today onwards, if we didn't know it before, is that in many questions at our level here, what comes in the later part of the question is often linked to what happened earlier in the question. So with that in mind, you will approach your other questions with that bit of information. So when I see 3 asterisks, 4 asterisks 5, I ask myself, is there anything that I did before that could help me now? And I zero in on 4 asterisk 5 because I recognize that we did 4 asterisk 5 just before. We found out that 4 asterisk 5 works out to be 23. Worked out to be 23. So therefore, I could actually make a substitution in this first part here, which I have to find. Because we worked out before that 4 asterisk 5 was equal to 23. Therefore, if we have to find 3 asterisks, 4 asterisk 5, it would simply mean that I will be having to find 3 asterisks, what? 3 asterisks what? 23. Right? Because we already worked out what 4 asterisk 5 was, and that makes our job quite easy. Because all we have to do now, as we mentioned before, is to recall what our asterisk means. We were taught, or they told us before, that x asterisk y, which means the relationship between any 2 variables placed before and after the asterisk, is governed by this function or this equation or expression. This expression, 2x plus 3y. So if we now have to find what 3 asterisk 23 is, we just place the 3 asterisk 23 below the x asterisk y, And observe now that the x is going to be linked to the 3 and the y is going to be linked to the 23. In other words, we're going to substitute 3 for x now and 23 for y. So it becomes 2 in brackets. Instead of x, we'll write 3 plus 3 in brackets. Instead of y, we'll write 23. Okay? And then we proceed. That would imply that 3 asterisk 23 will be equal to 2 multiplied by 3, 6. 3 multiplied by 23, 3 3s are 9, 3 2s are 6. So that'll be 69 plus 6, and that works out to be 75. Okay, so your answer there will be 75. Okay, so write down that. Make sure you have it. Okay, so we have this one up for you to look at. If A dot B is equal to a quarter square root of A squared minus B squared, and A equal to 5 and B equal to 3, find A dot B. Find A dot B. Okay, so try it out. Tell me what you get. Okay, so in this question, A dot B. The dot is what is known as the binary expression. Yeah, this is a binary expression because the dot is telling us that if we have a term A before it on the left and a term B to the right of it, then this is what we have to do to A and B. Whatever A is, we have to square it, and minus whatever B is, we have to square it. And when we do that, then we find the square root, and then when we do that, we multiply by a quarter. That's what this is telling us to do. It's a command. Okay? So, A is 5 and B is 3. So it means that if we have to find A dot B, I'll have to put A as 5 here. Right? And I'll have to put B as 3. But what does that mean? What does that really mean? It means do this. It means do this to it. Which is wherever I see A, it will be linked to 5. And wherever I see B, it will be linked to 3. In other words, the A is going to be substituted with 5, and the B is going to be substituted with 3. Okay? So those people who didn't know exactly how to start, this is how you start, right? Then, you put it in here. A quarter square root of A squared will be 5 in brackets, squared, remember to put your brackets, minus B in brackets will be 3. Again, we're squaring it. Follow it? Right. So what happens now? This becomes a quarter square root of 5 squared is 25 minus 3 squared is 9. So this then works out to be a quarter square root of 16. Now here is where 99% of the errors occurred. Right here, for everybody. Everybody. One error I saw in about 3 or 4 people making is they wrote the next line as, and I'll put it here in blue so that everybody's aware of the error. That is a common error, but not as common as the last one. As the second error I'll show you, which is some people wrote a quarter square root of 4. The square root of 16 is not the square root of 4. Those who wrote it, how could it be? 16 and 4 is 2 different numbers, aren't they? So you can't write the square root of 16 is square root of 4. No. Impossible. So those who have it, take note of that. Right? Square root of 16 cannot be the square root of 4. Because 16 is a different number to 4. Right? So logically that wouldn't be correct. So this is wrong. The next thing that most people had was a quarter times the square root of 16, and they put 4. That's the majority of people who went to this point and would normally think that is right. And they would think it's right because if you even go to your calculator and you're pressing 16 and do square root, you're going to see 4 come up. Right? But the square root of 16 is not 4 only. It is plus or minus 4. A square root has square root of a number has two solutions. Always a positive and a negative. And if you want to try it back, you know square root means find that number which when multiplied by itself gives me back the original number, isn't so? Isn't that so? So let's try it across here. 4 multiplied by 4 is 16. So that's valid. But what about minus 4 multiplied by minus 4? Isn't that also 16? Good. So what you learned today is that when you have to find the square root of a number, it would not be totally correct. In fact, it would be incomplete if you just put down one root, which is the positive root. You must put down the two of them, plus or minus 4. This is always the case. And from here now, if this is what we're looking at, so your solution should have read a quarter multiplied by plus or minus 4. And then from that stage now, a quarter times plus or minus 4 will be plus or minus 1. A quarter times 4 is 1, and a quarter times minus 4 is minus 1. Okay, now this is important because if you had only written down the 4, you would not have gotten full marks. You would have lost those marks. And those marks are the ones that could probably tip you over into a distinction if you're looking for that. Yeah? All right? So you have to be convicted enough to do what is right. This is the correct thing, plus or minus 1. And, you know, this becomes even more significant, for example, if you were faced with a simultaneous equation and you had to find the values of x and y, and you only selected positive 1 for x, then it means you would have not gotten the other value for y, because remember, y would be based on the other value of x, which would be the negative 1. So you'd see how that comes along even more. So this is important. Take a note of it. See where you went wrong and fix it up. Okay, so we have if m square or box, let's call it box, m box n is equal to 2m plus n. They ask us to find what is 3 box 5. So this one could be worked out quite easily. Let's do it right here, because that shouldn't take much time. If we have m box n is equal to 2m plus n, like that, then we want to find 3 box 5. All it means is we're going to remove the m and place 3, remove the n and place 5. So it'll be 2, m is replaced by 3, and n is replaced by 5. So it works out to be 6 plus 5, and 6 plus 5 is 11. So that one was relatively easy, nice. Everybody should be comfortable with that one. Okay? The box is just linking the m and the n. In this one now that we're going to look at, it says find the value of x such that x box 10 is A10. Now, if we recall that, again, m box n is equal to 2m plus n, all this is telling us is that the box joins whatever comes before it and whatever comes after it by this relationship. The box joins whatever comes before it and whatever comes after it by this relationship. So if we look at x box 10 and put x box 10 right below it, as I indicated to you is the solution for this all the time, you notice that what comes before the box here is the x, and what comes after the box is the 10. So it means the x now is going to take the place of the m, and the 10 is going to take the place of the n now. That's all it means. The box joins what comes before it to what comes after it by this relationship. So 2 by, instead of m, we're going to write x, plus, instead of n, we're going to write 10. So this works out to be 2x plus 10. So x box 10 is really 2x plus 10. If x was a number, you'd have just replace it and you'll get an answer one time. But it was a variable. X is something that is varying. Okay, so we put 2x plus 10. But we also know that x box 10 must be equal to what? 810. Therefore, from those two equations, we could write 2x plus 10 must be equal to what? 810. Because this is 2x plus 10, which is x box 10. And x plus 10 is also equal to 810. So therefore, these two must be the same. Right? Because they are both x box 10. So if 2x plus 10 equal to 810, then it comes down to an easy solution. 2x equal to 810 minus 10. Minus 10 on both sides. So 2x will be equal to how much? 800. And therefore, you could solve what x is now by dividing on both sides by 2. Therefore, x will be equal to 800 over 2. 800 over 2, which will be equal to 400. So the answer there is 400. X is equal to 400. There, but you can. Okay. Okay, so under this topic, which is the difference of two squares, I'd like you to write the note. And the note is the difference of the squares of two numbers. The difference of the squares of two numbers, which is commonly referred to as the difference of two squares. Don't write that, but it's commonly referred to as the difference of two squares. So the difference of the squares of two numbers is the product of the sum and the difference of the numbers. The difference of the squares of two numbers is the product of the sum and the difference of the numbers, i.e., a squared minus b squared, a squared minus b squared is equal to, open brackets, a plus b, close brackets, a minus b. Up on the board. So the difference of two squares, that's a commonly known name, which is really the difference of the squares of two numbers. One number being a that is squared and another number b that is squared. The difference of those two numbers that are squared is equal to the product. Product means to multiply. So it means that there's a multiply sign here, is equal to the product of the sum, that sum means to add, and difference means to subtract, of the two numbers. What were the two numbers that were squared? One number was a and the other number was b. So that's what it means. So as an example, our first example is to prove what we just said. If I say 10 squared minus 5 squared, according to our rule that we said was the difference of two squares, it will be equal to the product, which means to multiply, of the sum and the difference of two numbers. The numbers that were squared, 10 was squared and 5 was squared. So I'd have to write 10 here, and 5 here, 10 here, and 5 here. So the difference of the squares of two numbers is the product of the sum and the difference of the two numbers. The two numbers were 10 and 5, 10 and 5. So according to what we are saying, this should be the same. So let's work out this side here and see what happens. 10 plus 5 is 15. 10 minus 5 is 5. And 15 multiplied by 5 is 75. If you work it out, 5 5s are 25, 5 1s are 5, and 2 make 7, 75. But before we did this, we would have worked out this a different way. 10 squared would be 10 by 10 or 100. And 5 squared would be 5 by 5, which would be 25. 100 minus 25 is also 75. So it's a proof that the technique is valid. This is how we would do it before. This is how we learn to do it now. And we know that the two numbers are the same. So we realize that this technique is correct. The equation is correct. So this is example 1. We're going to do example 2 right after you take that information down. Now, a common question in the exam, is to factorize different expressions. It normally comes as question 2. And in that question, you're expected to know how to factorize in all different ways, using the HCF, using factorization grouping, using the difference of two squares, which is what we're going to learn now, and so on. About 4 or 5 different ways. They're not going to tell you which one to use. You are expected to recognize which ones to use. So now, if they say factorize in the exam 1 minus a squared, you have to decide what method am I going to use. If you look at this, you realize that I can't take out any HCF. There's no HCF there. I can't do factorization by grouping because factorization by grouping requires us to have 4 terms. There's only 2 here. And then you might say, but listen, we have to know how to factorize using the difference of 2 squares. So this may be the difference of 2 squares. Then you ask yourself, well, okay, I'm seeing a number squared here, which is a squared. I'm seeing the difference, which means the subtraction sign. But this number here is not something squared. If it was something squared, then it would be the difference of 2 squares. So you ask yourself, could I easily represent 1 as something squared? Or in other words, what squared will give me 1? 1. So therefore, this could be written as 1 squared minus a squared. Not so? And if it could be written as that, then we could use our difference of 2 squares relationship. Because if we have the difference of 2 numbers squared, we know it's equal to the product. Product means what is between here is product. The product of the sum and the difference of the 2 numbers. What are the 2 numbers? One number is the number 1 and the other number is a. So you put 1 here and a, and you put 1 here and a. So the factorization will be 1 plus a multiplied by 1 minus a. So really it will be 1 plus a, 1 minus a. 1 plus a, 1 minus a. Okay, so you could write that. Okay, let us say we were asked to factorize 16 minus 25q squared. We have to factorize this. And by looking at it, we may determine that it's possibly the difference of 2 squares. Because we've seen a different sign, which is a minus sign. We've seen a number that is squared, which is q squared. And we may be saying to ourselves that maybe I could express 25 as something squared and 16 as something squared as well. So we ask ourselves, what squared will give us 16? 4. So we write 4 squared will give us 16. What squared will give us 25? 5 squared will give us 25. And what squared will give us q squared? Of course, q squared. So this here is equal to 4 squared minus 5 squared q squared. I could then write this here now as 4 squared. And this here I could write it as minus 5q all squared. Because the square here placed outside the bracket means that the squared will operate on the 5 as well as the q once you expand it out. So 5 squared q squared is the same thing as 5q all squared. Right? That's important. What you have to remember is that this here is not, right, is not the same as 5q squared. Okay, some people write this here and think that is equivalent to that. That is not so. They are not equal. Okay, so don't make that error. This is the correct expression for the 25q squared. And only when you reach this point, then you could make the statement that this is the difference of two numbers squared. One number is being squared is 4, and the other number or term that is being squared is 5q. So based on that, I could write in the brackets that is the product of the sum and difference of the numbers that were squared. One is 4 and one is 5q. So I'll write the 4 and the 5q right here, and I'll write 4 and 5q on the other side as well. Okay? So that's how you would work that one out. So take that. So we have up on the board now 25a squared minus 81q squared. I'd like you to factorize that for me and tell me what you would get. Okay, so we're looking at 25a squared minus 81q squared, and we are required to factorize it. So again, we recognize it's a difference. We're seeing a difference or minus sign. And then we see two terms squared so far, a squared and q squared. And then we start to ask ourselves about the 25 and the 81. Is there a way that we could express those as something squared? So we ask, what square will give me 25, or what's the square root of 25? And the answer will be 5. So 5 squared will give me 25. A squared remains minus what squared will give me 81? And the answer is 9 squared will give me 81. Okay, so that is what is equivalent to. But then 5 squared a squared could be written as 5a all squared. And 9 squared q squared could be written as 9q all squared, like that. And we recognize that this is the difference of two numbers that are each squared, commonly referred to as the difference of two squares. And we know that that would be two things in brackets multiplied by one another. In other words, there's a product. Product of the sum and the difference of the two numbers that were squared. One number or term that was squared was 5a, and the other one was 9q. So we just fill it in the brackets, and these would be our required factors. That would be the required factorization. Okay, so the topic is quadratics and factorization of quadratics. Let us first write a note as to what a quadratic expression is. And you're writing, a quadratic expression is one of the form ax squared plus bx plus c. Ax squared plus bx plus c. Where a, comma, where a, comma, b, and c are real numbers. Where a, comma, b, and c are real numbers. And we'll do an example to illustrate what this means. And in this example, we want to find the values of, you write in, find the values of A, B, and C. Find the values of A, B, and C. And I'm writing down the quadratics here for you. 2x squared plus 3x plus 4. 2x squared plus 3x plus 4. I want you to tell me what A is, what B is, and what C is. What is A, what is B, and what is C? Okay, so what is A? A would be the number 2. What's B? 3. And what is C? 4. So that was a nice easy one. A, B, and C, very easy. So that'll be 1. Let's look at another one. If we add x squared minus x plus 1. X squared minus x plus 1. What would it be A, what would be B, and what would be C? What would be A? 1. What would be B? I hear in 1, I hear in minus 1. It would be negative 1. What will be C? 1 again. Good. We're going good so far. Third example. Minus x squared plus 1. Minus x squared plus 1. That's what we're looking at now. What is A? What is B? Is B really 1? Let's go back up here. B is the number in front of x. C is a number that stands by itself, which means a constant term. So in this expression, are you seeing any x terms or terms with x? Which means that there's 0 x terms, right? And therefore the number in front of the x term will be 0. So this was sort of a trick question in that what you would have had to do in your mind was to recognize that this is the same thing as minus x squared plus 0x, because there's no x term, plus 1. So therefore, in this case, A would be minus 1, B will be 0, and C will be 1. Okay? And the last one, which is number 4, I'll write it on the board here. X plus 2x squared minus 1. X plus 2x squared minus 1. That's the next one we're looking at. Okay, we're looking at x plus 2x squared minus 1. What is a? 1. Is a really 1? Look at it again. What is a? Let's come back. A is the number in front of what? X squared. So what is the number in front of x squared down here? 2. See, it's a trick question again. Because what could happen in your exam, they could rewrite the order so that they write the x term up front, then the x squared, then the minus 1. You understand? So what you have to realize is that it could be done so, and therefore always have in your mind that the form of the quadratic that we are using is ax squared, where the x squared term comes up front. So let's put it in a way that will be more convenient to us. So we put the x squared term up front, so we put 2x squared, followed by the x term, which is x, followed by the constant, or the one without the, which is the number alone, that's minus 1. So now, it'll be a lot clearer what a is, because a would be the number in front of x squared. And what is a again? 2. So we write 2 here. And what will be b now? 1, because b is the number in front of x, and in our expression, the number in front of x is understood to be 1. And what would be c? Minus 1. Okay, so I hope that was useful. And in fact, this is how it comes at times, so that you have to be able to rearrange it. All right, rearrange it accordingly. And we'll close off with that quadratic at this time until the next class.